Let us start a new chapter today, sets. Now this is the first chapter of class 11th, first chapter of class 11th, as well as it is a foundation of mathematics, right? It is like a basic mathematics chapter. This will be used in every chapter that we will study in mathematics, almost everything. Okay. So what is set? Set is basically a well-defined collection of objects. Well-defined collection of objects. Now there can be various collections, right? Like collection of rivers flowing through India, and then there can be collection of dangerous animals, right? One I said collections of rivers flowing through India, right? And second that I said was collection of dangerous animals, dangerous animals. Now let us discuss these two cases first, and then we will be able to define set. When I say rivers flowing through India, now if you have basic knowledge of geography of India, you will know that which are the rivers that flow through India. Otherwise you can check it from various sources. If I ask you whether Ganga belongs to the rivers flowing through India, you will say yes, right? Because Ganga flows through India. And if I ask you whether snake is a dangerous animal, you may or may not find snake as a dangerous animal, because in some countries they may not find snake a dangerous animal. In some of the countries they may find snake as a dangerous animal. Even in one country, some communities might not find the snake a dangerous animal, and some communities are very afraid of the snakes because they find it very, very dangerous. So about the first set or first collection, I would say this is a well-defined collection. Well-defined collection where you can say with certainty whether something belongs to this set or not, right? If I talk about a river Nile, now whether this belongs to this collection or not, you will say no, because it doesn't flow through India, right? You can say that with certainty. But if I ask you whether cat belongs to dangerous animals or not, you cannot say something about it, because there are people who will find a cat a very dangerous animal, right? And there are people who will not find a tiger a very dangerous animal. So it depends on person to person, right? So this second collection is not well defined. So you cannot say with certainty whether some animal belongs to this category or not, okay? Because it depends on person to person. So a well defined, now this is the key word, a well defined collection of objects is called a set, right? And we denote sets by capital letters, for example A, B, X, right? Now these are letters, capital letters used to denote a set, and small letters are used to denote the elements or the objects that we were talking about, right? Elements or objects. These are sometimes called members also, right? So capital letters we will use to denote a set. Small letters we will use to denote the elements or objects or members inside that set, right? And let me tell you about some more symbols. Now there is this symbol. This is epsilon, right? This is a Greek letter, epsilon. This means belongs to, belongs to. So when we say that this particular element belongs to this set, so we mathematically write A belongs to capital A. That means this element A belongs to this set A, right? If let us say you know that this was the list of elements, right? This was only the list of elements, and this was not, there was no other element that was there in the set. So if I ask you whether X belongs to this collection or not? I have written only A, B and C. Okay, so X, you will say, doesn't belong to A, let us say. Okay, all right. So this means belongs to, this means doesn't belong to. As I said, the river Nile doesn't belong to the rivers flowing through India. So this will be the symbol that we will use. Now these are the braces that are used to write the elements of a set. So for example, if I got a set A and it has got elements A, B and C inside it, so how will I write it mathematically? This is not the correct way of writing it. So correct way of writing it will be A is equal to, now these braces, and inside these I'll write the elements separated by comma, right? So this set A has got these three elements, and mathematically I'll write it like this: set A is equal to these curly brackets or braces, and then there will be these elements separated by these comma. So if I ask you how many elements are there in this set, you will say 3 elements, right? So these are the brackets that will be used to write a set. You cannot use these brackets because these will have a completely different meaning, right? Because if I write, let us say 1 comma 5 in these brackets, these are known as open brackets, okay? And then there are these 1 comma 5, let us say I write here, these are closed brackets or braces, you can say. Now these are the brackets that we will use to write the set. Why will, now in this chapter particularly, or let us understand the meaning of these three. This means that if I write, let us say X belongs to, X belongs to, and X belongs to here. Now what I mean is that X has got all the values between 1 and 5. This first bracket means that X has got all the values between 1 and 5. Now how many values are these? These are infinite values, infinite numbers, because there are infinite numbers between 1 and 5. So all those numbers are written here when I use these brackets, right? So which numbers are not included? This 5 is not included, this 1 is not included, right? That's why I use these open brackets. When I use these closed brackets, that would mean that X is less than or equal to 5 and greater than or equal to 1. This is the meaning of these brackets. Now this bracket is what we are going to use for this chapter to write a set. This would mean that X is either 1 or 5. There is no other value of X, all right? So if I ask you how many values this X has, so you will say only 2, 1 and this 5. In these two scenarios, there are infinite values of X that are possible, all right? So these are the ways we will denote a set, okay? Now this is one of the ways of writing the set. There can be broadly two ways. One is set builder form, another is roster form or tabular form, right? So roster form is nothing but that we write these brackets and write the elements inside. For example, I have written these 4 elements inside these brackets, so that would mean this is the roster form of denoting a set. Set A has got these 4 elements, 1, 2, 3 and 4, right? So whatever is written inside this, or whatever you can see directly, is there inside this set. But in set builder form, we write the set in form of a rule. For example, if I need to write a set X and it has got element, let us say 3, 6, 9, 12, okay? So this is a set x that I need to write in set builder form. So what I'll do is I'll write x is equal to, and then the brackets start, x such that x is equal to 3n, where n belongs to natural numbers, right, and n is less than equal 4. So when I write this will mean that n belongs to natural numbers and n is less than equal 4. So that would mean n is 1, 2, 3 or 4. These are the 4 possible values of n. So if I put n equal to 1, 2, 3 and 4, then what are the values of this x that I get? When I put n equal to 1, I'll get 3. When I put n equal to 2, I'll get 6. Similarly 9 and 12. So that would mean that the elements that I've got in this set are 3, 6, 9 and 12. Now when I write x, so that means all values of x, such that these semicolons or colon will mean such that. This colon will mean such that. So all values of x such that x is, then this is a formula that we write, right, which satisfies all these values that we have got in this set. So x is equal to 3n, right, where I need to define n now. N belongs to natural numbers and n is less than equal 4. So this will give me the required set in set builder form. This is the set builder form, and where we write the elements directly, this is roster form or the tabular form. Okay. And there are some letters that are used to denote some particular type of sets. For example, this capital N, if you see capital N somewhere, this is generally used to denote a set of natural numbers. Similarly, if you see R, it denotes set of real numbers. Q is generally used to denote set of rational numbers. And Z or Z is generally used to denote a set of integers. Now, what are natural numbers? You already know. These are 1, 2, 3, and then it will go on like this, right? 1, 2, 3, 4, 5, 6, 7. Now, what are real numbers? Real numbers are all the numbers which lie on the number line, right? We studied about real number line in class 9th and 10th, and we have been studying about number line from the junior classes also. So all the elements that lie on this number line, right, we write it like this. So all the numbers that lie on this line, right, the number line is not only about the numbers that you see on it, right? This is about all the numbers that can lie on it. Between this 1 and 2, there lie infinite numbers, right? So we have studied about this. So there are these infinite numbers between minus infinity, because this goes to the negative infinity, and here it goes to positive infinity. Infinity is not a number, we know. Infinity is just a notion. So when we need to write this set of real numbers, we will use these brackets, open brackets, right? So we will write it as minus infinity, comma infinity, and that will mean that this open bracket will mean that these infinity are not involved, right? So this set doesn't give you a value infinity, as infinity is not a number, right? Between minus infinity and infinity, all the numbers that lie on this number line are being represented by this set, right? So, and what about rational numbers? Rational numbers are those numbers which can be written in the form of p by q, right? For example, if I write p by q where q is not equal to 0, now these are rational numbers. What are integers? These all are integers, -2, -1, 0, 1, 2, 3, right? And you will have integers which are positive, integers which are negative. For example, if I want to write only the positive integer, I'll write z, and then there will be this plus sign. So what are positive integers? 1, 2, 3, 4, 5, and so on. So positive integers are nothing but natural numbers. Positive integers mean natural numbers, right? But when I say non-negative integers, this is a kind of revision, right? Non-negative integers are whole numbers. We sometimes denote it by W, capital W. So what are these? 0, 1, 2, 3, and so on. So these are non-negative integers. These were positive integers, right? Similarly, you can write positive real numbers like R plus. So these are some of the capital letters that are used to denote some particular types of sets. Now let us move to exercise 1.1 and examples that precede that exercise 1.1.